In this lesson, we're going to be looking at the graphs of 4 different functions. All of them are a little weird. I'm just going to tell you up front, all of them, we don't use the graphs that much. I think it's useful to look over for a little bit, useful for you to see, but do know that it's most important simply to know the graphs of sine and cosine, which, coincidentally, I've just put on the screen right now. You should be very, very familiar with the graphs of sine and cosine. Anything that we need to do with trig, you can really figure out just through these graphs. Anything I ask you about the graphs of tangent, cotangent, secant, or cosecant, you can figure out, understand, know what to do just by knowing the graphs of sine and cosine. So do take a minute to pause the video, copy this down. Might be the first time in notes that you've actually have 2 cycles shown of these graphs. So do make sure you take the time to do this well. Couple things that I did not put down. Obviously, we know the maxes and mins for sine and cosine are at 1 and -1. We go to, it looks like I put a negative pi here for some reason. Positive pi, positive 2 pi there. This would be pi over 2. This is 3 pi over 2. This would be negative pi over 2, negative 3 pi over 2 if you care. You need to know that sine initially starts at 0, 0, while cosine starts way up at 0, 1. So again, pause if you need to and copy down these graphs. Okay, I'm going to erase what I have up here. And, of course, our fun friend would show up. I know I said a while ago I was going to register this, and I do plan on doing that, but every time I come out to make some videos, I just want to make videos. I don't want to spend time figuring out how to register, but at some point I will, I promise. Okay, how do we graph the tangent function? I'm going to show you Sketchpad for just a little bit here. Remember that tangent is sine over cosine. Okay, that's really important to remember. So I want you to think about what's going to happen when sine is 0. When sine is 0, this whole fraction will be 0, which means tangent is 0. Sine is 0. If you go back and you look at the graphs that are up above, sine is 0 at the beginning and at pi. So the graph of tangent should go through the x-axis at those same points. And then I want you to think about what's going to happen to this graph of tangent when cosine is 0. When cosine is 0, I am dividing a fraction by 0. I get undefined ideas, and generally that means a vertical asymptote. Cosine is 0 at pi over 2 and at 3 pi over 2. So that means on my graph I'm actually going to have a vertical asymptote right here. And also at 3 pi over 2. Okay, now it gets a little trickier. Let me add a few more there. Okay. I need you to think a little bit about what's going to happen in each of the, you could almost say, quadrants of our unit circle. As I go in this part, and then in this part, and then in this part, and then in this part. So it might also be helpful to remember that sine is kind of like y, and cosine is like x. Okay, all those things are kind of true statements as long as we're thinking about the unit circle. So in the first quadrant, both y and x, sine and cosine, are going to be positive. So in this part right here, this is from angle measures 0 to pi over 2. That's the first quadrant. I should expect the graph of tangent to be positive. I don't know exactly what it's going to look like, but it should be positive. In the second quadrant, which would be pi over 2 to pi, so anytime I'm on the unit circle in this part, y is positive, but x is negative. So if I divide those two ideas, I'm going to get negative things here. Okay, in the third quadrant, both are negative. Both x and y are negative. And if I divide those two ideas, I would end up with actually something positive. So my graph should be somewhere up there. And then in the fourth quadrant, x is positive, y is negative. I should end up with something right here. So what's that going to look like in the end? Well, if I know that this goes through the point 0, 0, 0, and I have to stay positive, but I'm heading toward a vertical asymptote, tangent should go or make a movement kind of like this. Okay, and then if I go to this middle chunk here, I know it's got to be at a vertical asymptote. It's got to be negative here, going through this point at crossing the x-axis and then becoming positive. It's probably going to do something kind of like this, and then would continue over here. So let's just see what happens when I actually say animate the graph of tangent. And again, this program is simply calculating for every angle measure what's that ratio of sine divided by cosine, or y divided, really it's doing y divided by x, I suppose. And so that's the graph of tangent. I know it looks a little confusing, but that's what we kind of get through that. Jot down any questions you have at this point, but I'm just going to continue on with our notes here. Okay, so I need to erase all of this. There we go. Okay, so the graph of tangent. First, we just want to take a little bit of time and get that graph written out. And I just did the cycle from 0 to 2 pi on Sketchpad. Here I want to show you 2 cycles. So we're going to go all the way to 2 pi on the right side, all the way to negative 2 pi on the left side. This would be a negative pi. This would be a positive pi. And it's probably helpful just to put the pi over 2 and 3 pi over 2 marks in there as well. Okay, so what we saw was it has to go through at 0, 0. At pi over 2 there was a vertical asymptote, and at 3 pi over 2 there was also a vertical asymptote. Oops, what happened there? That was quite odd. We might be starting that over here a second. Okay, negative 2 pi, 2 pi, pi. Okay, so again, what do we know? We knew that right here it went through the x-axis. Here it's going to go through the x-axis. Here it's going to go through the x-axis. There and there. That means we have vertical asymptotes right there. And I think it just doesn't like me doing my vertical asymptotes. Maybe I'll have to change that a little bit. See if this comes back up or not. Sorry about that, folks. Okay, I'm going to pause it and get my picture to look really, really good for you, and then we'll continue. Okay, so that is what our graph of tangent would look like in the end if we had to do cycles from negative 2 pi to 2 pi. And again, just kind of remembering where the x-intercepts are, where the vertical asymptotes are, thinking about where the quotient of y divided by x on the unit circle would be positive or negative. Okay, one typical kind of question for any of these functions would be over on the right side. Describe the graph of the function y equals negative tangent of 2x plus 1 in terms of tangent of x. So thinking BHAK. So let's list a bunch of stuff off here. First of all, I know that from that 2, I have a horizontal shrink by a factor of 1/2. Okay, that's my B value. I don't have an H value in this case, so now I go to my A value. My A value is just a negative symbol there, so that's reflecting over the x-axis. And then the plus 1 is my K value. I'm just going to shift up 1. So really for any of these sorts of questions, any of these functions, I could certainly have just describe the movements, describe how you would take this function and modify it to fit a function like this. Okay, that's our video on tangents. Next one will be cotangent, but I'm going to stop it right here.